So H2CO3 is an ingredient in the pulp that makes it carbonated or fizzy. So it undergoes a decomposition reaction to produce a desired carbon cation or fizziness. So to understand whether H2CO3 is an acid or a base, we have to understand the definition of an acid. It collects more H plus. So in simple terms, it has a grade more H plus than OH. An example of an acid is HCl, while a base is it collects more OH. And in simple terms, it's just there is less H plus than OH. And an example is NaOH. So there are also properties within an acid and a base, but by just looking at the formula, the molecular formula over here, so H2CO3, you can tell that since there is more H pluses, this is an acid, so H2CO3 is an acid. And this is based on the Bronsted-Lowry definition. So in order to fill out what the product is, we have to understand what a decomposition reaction is. And a decomposition reaction means we're going to take this molecule, H2CO3, and we're going to break it apart. Because a decomposition reaction is like a gigantic puzzle. So each gigantic puzzle is made out of smaller pieces, and H2CO3 is like the big picture, and we're going to take apart the molecule. So what happens is we're going to draw the Lewis dot diagram first. So that's the first step. You have to draw the Lewis dot diagram. So the Lewis dot diagram is like this. So because carbon has the most bonding sites, it has 4 available bonding sites. So it means that it's going to be our central atom. So that's where all the other atoms will bind to. So because there's 4 bonding sites, oxygen usually forms 2 bonds because it has 2 valence electrons. Bonding, and then we're going to have on this side, we know there's going to be 3 oxygen. So we're going to make an oxygen on this side. And then on the other side of the structure of oxygen, because it has another bonding site, it's going to be the H, the hydrogen. So this is your Lewis structure. And don't forget to put the electrons. So you always have to fulfill the octet rule. So in the decomposition reaction, it's gonna, so what happens is that we're gonna form water. And in order to do that, what happens is the bond between the oxygen and the carbon is going to break. So it's going to detach itself, and it's going to become hydroxide on this side. Then you're going to be left with this unstable molecule. So both molecules are unstable. And remember what the goal is each molecule wants. They always want to have to fulfill the octet rule. They want to be stable. They don't want to be unstable. So they're unhappy this way. So what's going to happen is that because hydrogen has a high affinity for electrons, and oxygen, since it has an open area because of this negative charge, what happens is that hydrogen is going to attach to oxygen because it has a high affinity for the electron. And because this molecule is very unstable, so this way hydrogen will fulfill the octet rule. And then we're going to get, that's how we form water. This is where the molecule of water comes from. You're going to get your H2O. Don't forget to draw the electron. And here, because now you're left with this molecule of carbon, and 2 oxygens. So this is a very unstable molecule. It can't stay this way. And like the goal is that they want to reach the most stable form. So in order to reach a more stable form, the oxygen, because this is a negative charge, sorry if it's hard to see that, it's going to create a double bond with carbon. So you're going to make a double bond, and then you're going to result in H2O and carbon dioxide. So here's our Lewis structure. And carbon dioxide. And then I just had to say that water was a liquid and carbon dioxide is a gas. And then for C is explain why this reaction makes the drink fizzy. So to do that, we can just think of a bottle of like Coca-Cola. So you have your bottle, Coca-Cola, your bottle, and it's closed by a cap. So within the drink, there's going to be your liquid portion, which is water. And here's your water. And then your gas. So the thing about gases is that they have a lower density. So they always want to flow out because they have more kinetic energy than water, and they're able to do so. But remember, we trapped it by a cap over here. So this causes a buildup of pressure up here. So this is where your buildup of pressure occurs. So it's going to form a pressure around near the cap because the gases want to flow out. They weigh a lot less than water. So what happens is when you open the bottle, still have our liquid here. It's going to stay there. But the gas, the carbon dioxide, has less density. So all the molecules are going to flow out. And that's going to cause the fizziness, is the release of pressure. All the molecules are floating around. And yeah, so that's the reason why your drink gets fizzy when you open the bottle.